Hey, what's up guys, welcome back to my YouTube channel, and today we are going to look at what is machine learning. So before we get started, I wanted to let you guys know that on Monday I will be posting videos on TensorFlow and deep learning. Basically in those videos we'll be using TensorFlow and Keras to build out machine learning models, and on Wednesdays I'll be posting videos on machine learning. So in the tutorial videos that I post on Wednesdays, in those videos we'll be looking at the mathematics behind the machine learning models, and also we'll be building those models using Python and scikit-learn. On Friday I'll be posting videos on Python. Well, that's because I wanted to make a short series for those who are new to Python programming, so that you don't feel left out in case you don't know how to program in Python. But it will be a basic series, so I won't go into advance of Python. But once that series is finished, I'll be doing two videos on machine learning. So Wednesday and Friday I'll be doing machine learning and the mathematics behind machine learning. Okay, so let's move on to today's topic. So what is machine learning? So on the internet, if you search for machine learning, you will find a lot of different definitions on what machine learning is. Well, that's because machine learning is such a wild field that nobody really knows what exactly to call machine learning. But in all those definitions, what you would find common is that they would say that machine learning is usually used to find out patterns, or you are given some data in machine learning and you have to derive something from that data or get some information out of that data. So that is something that would be common in all those definitions. So I'm going to give you my definition of machine learning. So according to me, machine learning is the process of designing algorithm to perform tasks that require some form of human interaction without that human interaction, by recognizing the patterns in those tasks, and or you can say by inferencing from the given data. So let me write that down. So if I go to the type tool, so if you're still confused about what machine learning is, let us look at some examples that will help you understand better what machine learning means. So these are some of the examples that have been tackled with machine learning before. The first one is spam filtering. So what is spam filtering? So when you go to your Gmail account, there is always this email that is trying to sell something to you, and for most of the time that kind of emails are quite irritating for most people. So what Gmail does is it automatically classifies an email as a spam or not. The process of finding out whether an email is spam or not is done through machine learning, although you would not call it learning, because it's just referencing stuff and not exactly learning something. We'll get into it later, but for now just know that spam filtering is done using machine learning. So the next application is called face detection. So now there are several reasons why you would want to detect faces. Well, one reason would be to identify criminals easily, and machine learning can do that quite easily. We might not be at that level yet that we might be able to say with 100% accuracy that it is going to find the correct person, but it's still a work in progress, and I'm pretty sure that in the future we will be able to do that. So the third one is called speech recognition, and so the most popular example would be Google Assistant or Siri. So personally, I play around with this functionality of my phone quite a lot, because it makes stuff so much easier, especially since Google updated the Google Assistant recently, and since then it has become much more reliable than it used to be, and I'm sure that in the future it will be even better. So this is one problem that we try to solve with machine learning. So the next problem is text auto completion. This problem is also solved using machine learning. So you might have seen that whenever you are typing something in Microsoft Word, or even in Windows, when you are typing something and you want something to be auto completed for you, you can turn on the auto completion feature, and it will auto complete what you are typing for you. So the next application or next example would be the recommendation system, and this one is quite a popular one. The most common example would be Netflix. So whenever you are watching something on Netflix, it automatically recommends you what you should watch next. Well, this is done through machine learning, and recently we have seen that it has become quite accurate. And the next example would be self-driving cars. And this is a problem. This problem is much more complex than all the other problems, because while teaching a machine to drive a car is easy, but it also has to take care of others. For example, because not every car is going to be automatic, or not everyone is going to be able to buy automatic cars that early on in the development phase. So this is one problem that can be tackled with machine learning. So what we try to do is we try to take in different forms of data from the surrounding and give it to our machine learning model, and then it decides what to do next. So that is one way to use machine learning. And the last example that I would like to give is called weather detection. And this problem is so much complex that we have been trying to solve this problem for decades now. And as you might have noticed that recently it got better at detecting weathers. That's because of IBM's recent development in quantum computing. So if you want to know more about that, you should definitely go to Google and check it out. So let's move on. So machine learning can be divided into three parts, and those three parts would be the first one is called supervised learning. So supervised, and the second one is called unsupervised learning, and the last is called reinforcement learning. So reinforcement learning is where most of the magic happens, and it is where you would find the most interesting projects. And for example, last year there was this challenge of generating new Pokemons from the older ones. That was also done through reinforcement learning. So I might show you guys how you can do that. Just let me know in the comments below. And I thought it was quite interesting. Okay, so let's move on to the next part. So let's look at each of these categories. Okay, so first let us look at what is supervised learning. So supervised. Okay, so in supervised learning, what you are given is a data set that looks something like this. So x1, y1, xi, and y. So you are given this kind of data set, and these are what you would call your input values, and this is what you would call your output or a label. So what your goal in supervised learning is that you want to find a function, so that when you give this value inside your function, it will return you this value. So so what you want to do is, let me write this function. So you want to create a function f, so that you give this value x inside that function, so xi, and it returns you some kind of output label called yi. So now this fx can be any kind of function. For example, it could just be x, so x could be equal to y directly, or x square is equals to y, or anything like under root x is equals to y. So anything So it can also be some constant. For example, I could say c plus x is equals to y. So this is what you're trying to create, so that whenever you give this input inside your function, it will return you this output. So to do that, we can further divide our supervised learning problem into two parts. The first one is called regression and the second one is called classification. So first let us look at what is regression. So let me first erase all this. So let us first look at regression. So in regression, what you usually do is you try to create some kind of line on your data, and this line defines your data, like it represents your data as best as it can. I'm saying that the regression would be a line. Well, that's not actually true. It can be a number of things. For example, if we were doing multiple regression and our data was in 3 dimensions, then it would be a plane instead of a line. So let me show this to you using an example. So I'm going to draw a 2D graph, and this is my y-axis and this is my x-axis. So on this graph I'm going to draw a data distribution. Basically I'm going to draw some points. So in this kind of problem, our goal would be to draw some kind of line that would best define my data. For example, I could draw a line like this, but this line would not be the best one, because as you can see, it is completely different from my data. So if I wanted to like predict some x value over here, so now if I wanted to find out this point over here in terms of y, what I could do is I could draw this line like this, and then I could just look at what this point over here matches on the y-axis. So what I'm saying is that my y value is this for this x value. So this would not be the most accurate one, but if I draw a line like this, now this is much more accurate than this one, and if I draw something like this, and this one is even better than this one. So if I wanted to find out a point over here, what I could do is I could draw a line like this. Now from this point I could just draw a line to the the y-axis, and wherever my imaginary line meets on the y-axis is my actual value of y. So this is what a regression problem would look like, or how you would solve a regression problem. So if I wanted to draw a machine learning model, what I would do is I would say this is my model, and notice that this line is my function. So whichever function describes this line is going to be my regression function. So in case of regression, my model would be a function. So I would create a function called f of x, and what I would do is I would pass in some kind of input. So input, and if I pass this input inside this function, this would give me a result or output. Now what I would do is I would compare my results to the already given labels. So for example, if my input was xj and my output should be yj, so what I would do is I would compare this value and this value together. So if my value matches, then I would say that my model is correct. Otherwise, what I would do is I would find out by how much margin my value is actually different from the correct output. So to do that, I would find out the error between the two values. So once I know this error from these two values, what I would do is I would pass this error back to my model, and using this error I would change my function a little bit or change my model a little bit, and I would continue until I get the desired results. So we'll look at this when we move on to regression. For now, just know that this is how a regression model works, and let's take an example of classification. So in classification, we try to classify our data points into classes. So for example, if you are given data set like this and you wanted to distinguish between those two classes, the one in black and the one in red. So notice that so notice that we are doing supervised learning, and that we already know during the training process what our labels are. So our machine doesn't know, but we know what our labels are in supervised learning. Keep that in mind, and let's move on. So what I can do is I can draw a line like this, and now everything that is beyond this line, a member of a class red, and everything on this side is a member of the class black. So we will take a look at regression and classification in great details in the coming lectures. For now, just know that in supervised learning your data is in this form, xi comma yi. So basically your output is already known to you and you are just given some input. You just have to find a function that describes your output. So that's it for supervised learning. Let's move on to the next part, that is unsupervised learning. So I'm going to erase all this. Okay, so now let us take a look at unsupervised learning. So unsupervised. So in these kind of problems, we are provided with the input variables, but the output variables or the output labels are not given to us. So what we try to do is we try to find out those classes or those labels. You might say that that is an impossible thing to do. Well, yeah, you cannot find those exact labels, but you can like get quite close to your original classes or your original labels. So let's take a look at what unsupervised learning is and how we perform unsupervised learning. Okay, so in supervised learning what we had was we had some input variables, and along with those input values or variables we also had some output labels. So in unsupervised learning what we are given is only the input values or the input variables. So in unsupervised learning this is what your data set would look like. So x1 comma x2 up to so on xi. So this is a basic example of what your data set would look like in unsupervised learning. Now these x values are not only one value, these might contain multiple values. For example, this x1 could have values such as x11, x12, and up to so on x1n. So this could have any number of dimensions. What I mean by dimension is that any number of input or any number of features. So features is what we call our input values in machine learning. So now if you wanted to solve this kind of problem, well, there are several ways you can do that. First one would be through clustering. The second one would be density estimation. And there are a lot more ways that you can solve these kind of problems, but I'm going to stop over here and we'll look at each of these algorithms or each of these ways and how and when we want to use these different kind of algorithms in unsupervised learning. So for now let us take a look at an example of what clustering looks like. I won't even go into density estimation because it might be confusing for you right now. So I'm going to show you what clustering looks like, and so let me first erase all this. Okay, so in clustering your data set would look something like this. So let me change the color. Now, this is the kind of problem that you can solve with unsupervised learning. Normally, you would not know what these labels are, even though I have given a different color to different clusters. But normally, you would not know at the starting of your project that what these labels mean, or your machine learning model would not know what these labels are, and it would have to find out on its own what these mean. Suppose that we do not know what label is what, so our goal is to differentiate between all of these three labels, so that we can so that, for example, if a new data point comes, we might be, for example, if the new data point was over here, we might be able to tell which cluster it belongs to. For example, if I draw a line over here, then that would mean that my data point belongs to either a red or a blue class. So but if I had another line over here, and now I know that my data point belongs to the red class, and at the starting of algorithm you would not know what a red class is, or what a green or a blue class is. And so using the unsupervised learning techniques, we will find those clusters. And so after we have trained our model, we will be given some kind of input or a new data point, and we would have to classify it using the machine learning model that we have just created. So that's it for unsupervised learning, and let's move on to reinforcement learning. Well, before we do that, let me tell you one thing. In supervised learning, we knew what our labels would be while training, but in unsupervised learning we do not know what these labels are. So this isn't exactly what our data would look like at the starting. This is the end result. So in the beginning of our machine learning model, or in the beginning of our problem, this is what we would have, for example. So now if you look at this data set, you might be able to tell what cluster is what, but if it was a machine, it would be very hard for a machine to tell that this data set is different from these two, or this one is different from this one. So this is what you would have at the beginning of our model, and after training our model on this data, it would give us something like this. So for now, let's move on to reinforcement learning. Okay, so reinforcement learning is kind of a combination of both unsupervised and supervised learning. Well, what I mean by that is, in reinforcement learning, we are given some input data, and our model tries to find out the output. But in this type of learning, what we do is we have some kind of way of telling our model whether it is going in the right direction or it is going in the wrong direction. So I won't go into details of reinforcement learning right now, because that would confuse you a lot. So for now, what I'm going to do is I'm going to show you how reinforcement learning is different from supervised and unsupervised learning. So in reinforcement learning, what happens is we provide some kind of input to our model. So suppose this is our model, and M, and it gives us some kind of output. Now what we do is we take this output and try to compare it to our desired results, and undesirable results. So if the result is the desired result, or our model is going in the right direction, what we do is we give it some kind of a reward. So reward. So but if the result is not desirable and our model is going in the wrong direction, we give it some kind of punishment. Now what we do is we pass this reward and punishment, so reward and punishment, whichever it may be, to our model. So now if a new data comes in, it will try to predict a new output depending upon our previous feedback that we have provided to our model, and it will try to do things differently this time. And so it might give us a better result now, or it might give us even worse result than before. So the feedback system is what makes this model quite versatile and usable in problems such as driving or weather prediction and stuff like that. So we will study more about reinforcement learning when we get to it, and that's it for today. If you have any questions, leave them in the comments below, and if you thought this video was helpful, you can like and hit subscribe. And if you want to be notified every time I drop a new video, you can turn on the notifications, and I'll see you in the next tutorial.